This is the part 2 video about graphing circles. This video is going to focus on graphing circles that are not in standard form, but instead are in something called general form. So jumping right in, it says for the equation x squared plus y squared plus 4x minus 6y plus 12 equals 0, they're going to ask us part A to find the center HK. So you'll notice I left a lot of room under part A for a reason. We can only find the center quickly if our equation is in standard form. It's not. We are dealing with a circle because my biggest exponent on x is a 2, and also my biggest exponent on y is a 2. So I do have an x squared and a y squared as my biggest powered x and y, so I do know it's a circle. If we think back to the formula in the last video for standard form, we said most of the time, not always, there would be parentheses, but you'd have this factored format around your x's and your y's. So it was the quantity x minus h squared plus the quantity y minus k squared equals radius r squared. So if I look at the equation we have, we definitely do not have it in standard form. How do I know that? Because everything has been multiplied out on the left side. I have an x squared separate from a 4x. I have a y squared separate from a minus 6y. You have different x's, different y's. Again, everything has been multiplied out. It's not in a factored format at all. So that tells me it's not in standard form. So when everything's multiplied out and it equals 0, that means that it is currently in general form. So again, general form for circles means everything has been multiplied out and it equals 0. So before I can find the center or the radius, if I have an equation in general form, I need to convert this to standard form. And the only way to go from general form to standard form is by completing the square, which is a little time consuming, but it's not bad once you get the hang of it. So before I can answer the question about what is the center, let's go ahead and complete the square to rewrite our original equation in standard form. So let me erase some of the circles here because it's starting to look a little too confusing with all these circles going on. So here are going to be the steps to this kind of lengthy algorithm every time you want to go from general form to standard form. So step 1, go ahead and just simply get your x's together and your y's together. So collect your like terms. So I'm going to bring down the x squared, but I'm going to write plus 4x right after it. So I haven't changed anything. I'm just getting the process ready to complete the square in step 1. I'll probably color code here. And then I'm going to write the plus y squared next minus 6y. So I put the x's first. I put the y's next. And then I'm going to also in step 1, if there's any sort of number without a letter, it needs to be moved to the right side. So I'm going to subtract the 12, opposite operation, to move the 12 to the other side. So equals negative 12 because I have 0 minus 12. So again, step 1, rewrite your x's side by side, rewrite your y's side by side, and do the opposite operation on the number by itself to move it to the right side. So I'm just slowly but surely setting the stage so that I can complete the square in step 2. So now here is step 2. My setup step is ready to go. We're going to complete the square. The formula to complete the square is take your b number, divide by 2, and square it. So it's b over 2, and those are in parentheses, squared. You're going to do it twice. You're going to complete the square for the x's, and then you're going to use this formula again to complete the square for the y's. When I say complete the square, what I mean is you're creating what's called a perfect square trinomial. So So every time we complete the square, we are creating a perfect square trinomial. Why do we care about a perfect square trinomial? Well, it's going to factor in a very, very special way. Those perfect square trinomials are going to factor in a way that's going to get our equation into standard form, as I have on the top of the slide. So, as I look at my x's first in red, b in this case is the number in front of x. So my b for the x's is 4. And then for the y's, my b number is going to be the number glued to y. So that's going to be -6. So let's go ahead one at a time and plug it into our completing the square formula. So when I put 4 into b, that's 4 divided by 2 to square. I do the division first. So 4 divided by 2 is 2, which needs to be squared. 2 squared is 4. So coincidentally, I get out 4 again. Now let's go ahead and plug in -6 that I have in blue pen into b. So -6, we divide by 2, and then we square it. -6 divided by 2 is -3 to square. Notice we are squaring the negative sign as well as the 3. So that's -3 divided by -3, which is +9. If you want to do these in the graphing calculator to save you time, you can as well. So once you figure out what to plug in to the formula and you get your numbers, you're going to add these numbers that come out from the formula to the end of the x's and the y's to get these perfect square trinomials going. So let me show you what I mean. As I go back up to step 1, bring down your x squared plus 4x. And we're going to add that 4 we got out from the formula at the end of it. So I promise we now have a perfect square trinomial with the x's. Bring down, go back up to step 1, bring down the plus y squared minus 6y. But you're going to add the 9 that you got from that formula. So now we have a perfect square trinomial with the y's as well. Go back to step 1, bring down the equals and the -12. But here's the catch. If I added 4 to one side of the equation, guess what? I got to add 4 to the right side of the equation as well. The same with the 9. If I added 9 to the left side of the equation, I need to also add 9 to the right side of the equation. So to summarize, these numbers that you get from the completing the square formula in step 2, you're going to add these numbers to both sides of the equation. So let's clean up what we have here. Put a little bar. So with the x's, we have x squared plus 4x plus 4. With the y's, don't forget you do have a plus symbol before the y squared, minus 6y plus 9. And then the numbers after the equals symbol, let's see, -12 plus 4 would be -8, plus 9 would be +1. So when you do -12 plus 4 plus 9, you do get a +1. So step 2 is definitely the most involved step. Don't worry, we are going to do a similar example here in a minute. I know this is a little time consuming, but I still have one more step, a step 3, so I need to erase. But the worst part is over. We now have the perfect square trinomials by the end of step 2. So let me just go ahead and bring up to the top what we have. So at the end of step 2, we now have x squared. Actually, let me color code it again. There we go. So in red pen, I have the x squared plus 4x plus 4, and then the perfect square trinomial with the y's plus y squared minus 6y plus 9, and then we had equals 1. All right, so the whole point of completing the square is to get these perfect square trinomials we said that will factor into a very special way. So step 3, the last step to get it finally in standard form, is to factor the perfect square trinomials. So factor means to rewrite in a multiplication format. Let's start with the perfect square trinomial in red. So I'm going to factor x squared plus 4x plus 4. I'm going to get my 2 blank parentheses ready to go. It is a 1x squared, so I can just think it out logically. So it must be x times x in the first spots. The first sign is a plus to drop down. Multiply your 2 signs together. Positive times positive is positive. And here's a really cool, quick way to factor perfect square trinomials. Our goal is still going to be to get the number in the middle. Let me rewrite this a little bit neater. So we had x squared plus 4x plus 4. This is step 3 we're on. So our goal is still to get the number in the middle. That's how we're going to know we factored correctly. So we want a positive 4x. And this little trick I'm about to show you only works on perfect square trinomials. So whatever is your third number in the trinomial, it's a positive 4 in this case, take the square root of that number in your head. So if you're asking yourselves, okay, what's the square root of 4? It's 2. And now if you check, and I put that in the last spots, that 2. Let's check. So if you were going to FOIL this back out again, you have the right answer because x times x is x squared plus 2x plus another 2x would be plus 4x. 2 times 2 is positive 4. So the reason, too, that this is going to work is the way that these should factor is you should have a match times a match. You should have the same thing listed twice, back to back. So I have x plus 2 times another x plus 2. They're not being creative with the name when they call it a perfect square trinomial. It's literally a perfect square of the same factor over and over again. So we factored x squared plus 4x plus 4. It factors to x plus 2, that quantity, times another x plus 2. Don't forget, you do have a plus symbol in between your perfect square trinomials. It's easy to forget. Now let's go ahead and factor the other perfect square trinomial, y squared minus 6y plus 9. So let's get our 2 blank parentheses ready. 1y squared must be y times y. The first sign to drop down is a minus. Negative times positive is another minus. And we said our quick trick way is to do the square root of the last number. It's a 9. So if I ask myself in my head, what's square root of 9? It's 3. So 3's go in the last slot. And if you check, minus 3 will give you back that middle term, which is negative 6, or negative 6y. And it looks like I'm on the right track because I have a match times a match, which is the special way that you should factor. I have y minus 3 times another y minus 3. And bring down the rest. So don't forget about the equals 1, which is on the right side. So because of the special way these perfect square trinomials factor, if I start over, I got x plus 2 quantity squared, because I have x plus 2 times x plus 2. Don't forget about that plus symbol in the middle. And I have quantity y minus 3 times y minus 3, which is really just quantity y minus 3 squared. And then we bring down the equals 1. Woo, so there it is. After 3 steps, we have converted our equation that was originally in general form into standard form. Yay! And now that it is in standard form, it's going to be very easy to find the x's, or excuse me, the center and the radius. So the center of the circle, once you have the equation in standard form, the trick was to just simply change the signs of the numbers trapped with x and y. So So the number trapped with x was a positive 2. So when I change the sign, that makes it a negative 2, comma. Now the y-coordinate, or the k as they call it in the homework, change the sign on the number trapped with y. So if I have a negative 3 trapped with y, I make it a positive 3. So the center of the circle is at negative 2, 3. Why am I changing the signs? Well, if you go back to the last video, we talked about the formula, that standard formula has a minus in front of the h, the x-coordinate of the center, and that minus, simply put, means to change the sign to find h. The minus in front of k means to change the sign to find k, the y-coordinate of the center of the circle. I'm going to bring my standard form equation over onto the next slide so then I can find the radius. So rewriting our standard form from part A, we said that we got the quantity x plus 2 squared plus the quantity y minus 3 squared equals 1. So part B wants us to find the radius r, and remember the way you do that is you take the number by itself and you always square root it. So the square root of 1 is 1 again. So my radius is simply 1. Now why do I do that? Because that lined up with r squared from the formula. That x minus h quantity squared plus y minus k quantity squared equals r squared formula. So because r squared lines up with 1, we do the square root to solve for radius r. So square root of 1 is 1 again. So now I know the radius and I know the center. I have enough information to graph the circle. It is going to be a teeny tiny circle since the radius is only 1. So I'm going to go ahead and throw my x and y axes on here. And step 1, you're going to plot the center first. If we look back to the last slide, we said the center is at negative 2, 3. So I'm going to go from the origin, left 2 boxes, up 3. We should make it right here in red pen. And then step 2, from the center, you're going to start now, and you're going to use the radius to count that many boxes from the center, and you're going to locate 4 points on the circle itself. The radius is only 1, so I'm only going to count 1 box from the center. So I go up 1 box from center, which is here, go back to center, 1 box to the right, back to center, 1 box to the left, back to center, and 1 box down. And then it's going to look like a square or diamond shape. Just try your best to sketch a circle. It'll be easier because you're going to be using a computer-generated circling graph tool in the homework. So it'll look much, much nicer in the homework. Now I am noticing, to save myself some time, part D is going to ask me to find the intercepts. And if you wanted to plug in, 0 into y to find the x-intercept, 0 into x to find the y-intercept, that works. And if you are going to do it that way, you're going to use your standard form equation. However, I'm noticing as I look at the graph of the circle I just drew, there are no intercepts. So I'm going to save myself some time because there are no points where that little tiny circle touches the x-axis, and there are no points on the y-axis where it touches as well. So there are no intercepts for this question. So we just said on the last slide, because it says part D, find the intercepts if any. Well, there aren't any. So you would select from a multiple choice option if this were your homework question. There are no intercepts, no points where the circle graph touches the x-axis or the y-axis. Let's try one more question where they give us the equation in general form and we need to use that 3-step procedure to convert it to standard form. So it says, the next example, for the equation 2x squared plus 2y squared minus 12x plus 8y minus 24 equals 0. Part A, find the center, HK. So this one is the hardest type of example they can give to you before we can even set up the equation properly, there is a 2 in front of x squared and y squared. So for us, it's going to be hard to get a perfect square trinomial if we don't have a 1x squared and a 1y squared. In other words, in step 1, you need to make sure that there is a 1 as the coefficient in front of x squared and in front of y squared. So if you see any other number in front of x squared and y squared, divide that number away. But I can't just divide two terms by 2. I need to divide all the terms on both sides of the equation by that 2. So you might see a couple homework questions where they have like a 2 or a 3 or a 5 in front of x squared and y squared with the general form. So before you do anything, divide that number out from all the terms. So when I do that, that leaves me with x squared plus y squared minus, let's see, we got 12x divided by 2 is 6x. Then I have, bring down the plus symbol, 8y divided by 2 is 4y. Negative 24 divided by 2 is negative 12 equals 0 divided by 2 is 0 again. There we go. So this right here is actually the general form we need to now convert to standard form. I had one little extra step at the beginning. So now we're ready to use that 3-step algorithm we discussed with the previous example. We said step 1 is just setting the stage to prepare for completing the square. So to do that, we keep like with like. So keep your x's together. So x squared, and then write the minus 6x after that. And then plus y squared plus 4y next. And whatever number is by itself, move it to the right side. So it's a negative 12, so I need to add it. Remember, you got to do the opposite operation to a term if you are moving it to the opposite side. So I now have 0 plus 12, which is a positive 12 on the right side of the equation. And there's an equal sign to bring down as well. All right, so step 1 is done. This is what I call the setup step. Now we're ready for step 2. This is the hard step. So just take your time. Remember, the formula to complete the square is the b number divided by 2 squared. So for the x's, my b number is negative 6. So I'm going to plug that into the formula. So I'm going to do negative 6 divided by 2 squared. Negative 6 divided by 2 is negative 3 to square. Negative 3 squared, or negative 3 times negative 3, is positive 9. For the y's, my b number is 4. Plug it into the formula. Goes into b. So 4 divided by 2 squared. 4 divided by 2 is 2 squared. 2 squared, or 2 times itself, is 4. After you get these numbers, you're going to add them to both sides of your equation from step 1. I know I have a lot of circling going on and messy handwriting, but what I'm boxing here in step 1, that is what the equation you're working with that you're adding the numbers to. So bringing that equation down from step 1, we had an x squared minus 6x to bring down, but we need to add 9 to it. Don't forget there is a plus in between your x's and y's to bring down as well. And now bring down your y squared plus 4y, which you're going to add this 4 to here. Bring down your equals 12. And then you need to add 9 to the right side as well, since you added it to the left side. And you also need to add your 4 to the right side as well. And let's see what we have here. So when we do that, we have x squared minus 6x plus 9 still, which is a perfect square trinomial. Bring the plus symbol down in the middle. In blue pen with the y's, we got y squared plus 4y plus 4. Bring down the equal symbol. So 12 plus 9 is 21, plus 4 is 25. So when you combine your numbers on the right side, you should be getting 25. So the hard part is done. Now I will mention here, be very careful. The two most common mistakes I've seen in class is people forget the plus sign that's in between those X's and Y's, and people forget to add the numbers to the right side. So they would write 12 instead of 25 by mistake because they forgot to add the 9 and the 4 to the right side. Little things like that, unfortunately, my math lab is going to mark it as wrong. So the hard part is done. So step 3, I'm just going to write up here. Now you need to factor your perfect square trinomials, which should be a match times a match if you do it correctly. So with the x's, let's see, we got x squared minus 6x plus 9. The first sign is a minus. Negative times positive is another minus. 1x squared is x and x. If I do the square root of the last number, square root of 9 is 3. So again, remember that little trick to factoring perfect square trinomials. You do in your head the square root of the last number. How do I know it works? If I do minus 3, I get back that minus 6x, which is my middle term, my goal. Again, don't forget, there is a plus symbol after that. Now let's factor the y's. So I have y's in the first spot. The first sign is a plus. Positive times positive is another positive. Do the square root of the last number. The square root of 4 is 2. Why does this work? We'll check it. Plus 2 gives you back the plus 4 as the middle term. And then let's bring over the equal symbol and the 25. So I know at the very least I'm on the right track, because when I factor these perfect square trinomials, I should get a match times a match. So I have x minus 3 quantity squared when I rewrite it with the exponent. Bring down the plus in the middle. And then with the y's, I got the quantity y plus 2 squared. And then we got equals 25. So there is my standard form equation. So now I can answer what's the center and what's the radius, since I have it in standard form. So I have no room, so I'm just going to do this off to the side. But my center, which is what it wanted in part A, we changed the signs simply on the numbers trapped with x and y once we have the standard form. So I have a minus 3 trapped with x. That's going to become positive 3. I have a positive 2 trapped with y, which will become negative 2. So my center here is the point 3, negative 2. I'm going to bring that standard form answer on over to the next slide to find the radius. And eventually, when you find the intercepts, you want to plug in to the standard form, not the general form equation. Let's look at the next slide. So B is find the radius r. So again, let's bring over our answer to standard form. It was the quantity x minus 3 squared plus the quantity y plus 2 squared equals 25. We said to find the radius, take the number opposite of the letters and take the square root of it. So the square root of 25 is 5. So our radius is 5 for the final answer for that.